Unite beyond boundaries. Innovate together. Joe's PANKRATIon 2024. No border.
Wow, go ahead.
Hello, my name is Subin Kim, and I'm here to present at the AWS PANKRATIon 2024. Today, I'm going to talk about the Slack gateway development with AWS Lambda. This talk would be particularly beneficial for anyone interested in developing Slack bots or handling external webhook requests. My name is Subin Kim, and I'm organizer of the AWS Korea user group. I'm also an AWS community builder since 2023, and I usually use Go and Python for my daily programming. Today's talk is as follows. First, I introduce the common architecture, then I explain the problems and limitations of this architecture. Then I explain the new architecture, and finally, I conclude today's talk with the conclusion. Let's start with the common architecture. This is the diagram of the common architecture. First of all, we get a Slack webhook request from Slack, which goes through ALB and ELB in AWS, which goes through ingress in the EKS cluster, and finally the request hit the API server pod. There are a few potential problems here. This architecture initially seems quite straightforward and effective for handling requests. However, as we dive deeper, some critical problems will be found. When the Slack webhook requests reach the API server directly, the requests will grow rapidly as the Slack messages grow. It can be hard to think of the case when the Slack messages spike, but I have often experienced, such as some monitoring bots like AWS or Sentry generating tons of messages, or some API servers logging modules can generate tons of messages. The API server's throughput increases dramatically, and the processing webhook requests delays the other requests. And eventually, the service that handles webhook requests crashes, and even the normal user requests cannot be processed normally. This is something that actually happened to me. Some certain microservices were logging to Slack so that the developers could quickly see and act on error logs, and others were logging to Slack, so some case like they could often see the payment history if the payment was made. When those services fail and the error logs explode, or when the payments explode due to the marketing, the Slack logs also grows with them. This automatically generates a lot more Slack messages than I have been experienced, which in turn generates a lot more webhook requests. I have been seeing this happen a few times, and it was hard to predict and prepare. As the number of the Slack webhook requests increases, the load on the DB gets heavier, and if it fails, the other non-Slack features will be affected. But that doesn't mean we can just keep increasing the specs on our API server or keep increasing the specs on our DB server forever. This is because it is not sustainable and it will increase the costs. So here are my proposals. So first, use the serverless. The front end that receives the request needs to be able to reliably handle the traffic. When we use serverless, it scales automatically without any manual action. It also needs to pre-process some of the data. And second, using the queue. Serving every request immediately to the server can put a load on our DB, and we might want to reuse the single event across the multiple API servers or multiple times. So we need to be able to monitor that when a webhook request fails to process, then we also need to be able to reprocess the failed requests. So I will introduce a new architecture that follows the previous proposals. So the new architecture uses these three services from AWS. The first is the Amazon API Gateway. Amazon API Gateway ensures that your API requests are reliably received at the front end. The second is AWS Lambda. Through Lambda, the Slack webhook request will pass events to the MSK after the minimal pre-processing. And finally, Amazon MSK. Slack events are passed to the MSK, which then process the event and makes it available to use for the other consumers. Then why we should the Amazon MSK? The Amazon MSK is an acronym for Amazon Managed Streaming for Apache Kafka. It is a managed service from AWS that helps you run and operate the Kafka cluster easily and reliably. The Kafka is a common and enterprise-ready message queue that it is often used to build the real-time or large-scale data pipelines. And it is easily scalable because of its clustered architecture, and a single event can be consumed multiple times through the multiple consumer groups. The Kafka's architecture is well suited for handling streaming data and it can efficiently manage the high volume of events generated by webhooks. So its ability to process the data in real time and can scale horizontally makes it a good choice for this use case. So this is the diagram of the new architecture. Similarly, we get a Slack webhook request, which is passed through the API gateway in AWS, which passes the events to the MSK with minimal pre-processing via Lambda. The consumers within the EKS cluster can consume events from MSK and reliably parallelize the process if needed. The advantages of this architecture lies in its simplicity and scalability. Each component can be scaled independently, and the use of managed services reduces the operational overhead and allowing developers to focus more on building the features rather than managing the infrastructures. So I have used the AWS SAM CLI for development, which was a great experience. The AWS SAM stands for the Serverless Application Model. The AWS SAM CLI allows you to develop locally to emulate the environments like API Gateway or AWS Lambda in AWS. It also allows you to start a server in your local environment, and you can also easily invoke events as your API Gateway or AWS Lambda. As you see in the slide, there is a script that I use to invoke, and I use my local file system's JSON file as an event. I can easily invoke the AWS event in my local environment. Also, the deployment is also very easy. All you need to do is build the functions inside the container and copy the built output and upload it via the AWS CLI. This deployment ensures that your code is packaged and deployed without any hassles. On the right side, there is an example of what I actually implemented using Go language. The first thing we need is some logic to handle the URL verification request separately. When the Slack initially registers a webhook endpoint, it has a process to verify that the webhook requests are authenticated and proceed properly using the Slack app signing script. This should be handled at the Lambda level. Sometimes the payload of the event is JSON, but sometimes it comes in a form, and sometimes it comes even something like base64 encoded. So you have to parse it separately for these different data formats, and after parsing, we can pass it to the MSK. So we can take it even much further. You can also use an ARM Graviton instance to save even more money. And you can also use a Kafka REST proxy to reduce the time it takes to produce events from the Lambda. And instead of flushing the producer on every request, you can change to flush it when the Lambda's SIGTIME signal comes in, like further reducing the produce time. However, using a Kafka REST proxy as one more point of failure and increase the cost of operating that proxy running reliably. The Lambda is more stateless than a typical API server. So since the entire life cycle should be completed in a single function execution, so the logic that takes in signals and handles them separately, it is not in line with the Lambda's philosophy, and it can be unstable. However, this leaves us with two concerns. First, how to handle the Kafka lags. Kafka lag refers to the delay between when a message is produced and when it is consumed. The lag can be a major issue from a UX perspective, as the events in the Slack can take a longer time to result in a response. So we need to monitor the Kafka lag regularly and take action when it increases. The easiest way to do this is to increase the partition number of the Kafka topic and increase the number of consumers in a consumer group to get more parallelism. However, once you increase the partition number, you cannot decrease it again, and it is hard to fix the underlying problems. So in this case, it is best to optimize your application so that it can process even much faster. If the event doesn't need to be processed based on the event payload, it is also a good idea to skip it and commit it as soon as possible. You can also optimize your consumer settings to make it more efficient to consume, such as you can also reduce network hop latency by pulling more messages, more records at once in a batch. The failed events might need to be handled differently depending on the reason why they failed. In Kafka, you can use a dead letter queue strategy. You can keep the failed events in a separate topic to automatically reprocess them later. Or you can take action by selectively issuing the events manually. In this case, it can be important to develop the consumers according to the principle of idempotent. So finally, let's summarize the conclusions and conclude today's talk. In today's talk, we talked about the various benefits and challenges of changing from the way we typically handle the wrapping requests to a new architecture. We used three AWS services. The first one is the Amazon API Gateway, and AWS Lambda, and Amazon MSK. And I showed you how to use them to handle the wrapping requests non-directly and reliably. Finally, I finished by introducing the AWS Korea user group, which I am contributing to. The AWS Korea user group is a group of users who use AWS in South Korea and currently has about 23 offline meetups. The meetups in Korea are categorized by topic and region. Something that's quite unique in South Korea is that there's a meetup for students called AUSG, the University Student Group. And there is also a woman developer meetup called Woman in Cloud Group. So they are very active and they are doing very many events actively. And I have been organized the University Student Group for the past year. And I'm currently organizing the Ujiro meetup, which is a regional meetup, and a platform engineering meetup, which is a topic meetup. So the AWS Korea user group also has a Slack workspace, so where we do a lot of questions and answers and advice and discussions and more. So I hope this presentation was helpful for you. If you have any questions for me or would like to know more about me, you can contact me using the contact information on this slide. So please pay attention to next other presentations. Thank you very much.